Can I ask you one question there? There is a one thing which is most necessity to us, other than, of course, we need most probably earth, air, water, sunlight. These are essential to us. Yes. Nowadays, there is a one more thing that is more essential to us. I'm not saying without that we may can't live, but there is one of the most essential that. Can you say that is what it is? Of course, food, water, air, land, clothes, shelter. That's a minimum needy things to the humankind. But one more thing else, that is very essential to us. Without that, that's imagination is very terrific. What is that? Yes, electricity. Let's begin the chapter electricity. That is, we know in our previous classes we learned that what is electricity is nothing but flow of a charge is nothing but a electricity. Flow of some charge is nothing but a electricity. So what is the charge? How we will get the charge? What is it particular? How the charge will be happens? Yes, in our PPT now we can observe and we can learn how this charge will be happen. From beginning we just learn how the charge will be happens. So here you can see all that charge is an intrinsic property. For which intrinsic property it is? Charge is the intrinsic property. For which intrinsic property it is? On the next bubble you can see there is a property of fundamental particles. So what are that property? How this intrinsic property? So charge is happening because of the intrinsic property of an atom. Clear? He just said that charge is the intrinsic property of an atom. So how this intrinsic property will be happens? So that will be happens because of the fundamental particles in the atom. The movement of fundamental particles gives a such a intrinsic property. Because of this intrinsic property, charge will be happens. So what are the fundamental particles there? Yes, electron, proton, positron, or neutron, boson. Do you know? Really 113 particles, fundamental particles, still now discovered when the atom bomb is of course exploded at Hiroshima and Nagasaki, at that place there. So at the time, by the research of the soil, the scientists found that nearly 113 fundamental particles is approximately available. Okay, so at the time of nuclear explosion we got it. Then now, so because of these fundamental particles, that is electron, proton, positron, whatever may be neutron, boson, so these produces these, because of this reaction the intrinsic property will be happens. So how this intrinsic property is that will produce electric and magnetic effects on by the particular atom. Clear? Because of its movement it will produce that electric and magnetic effects of the particular atom. I think you may learn in your previous classes that the electric field will be always coincides with the magnetic field. Obviously, conversely reverse. Vice versa, magnetic field also coincide with electrical field, right? Why? Because I said you may learn in your further class also in your later on you will learn in your magnetic effects. There is a magnet that is lesson, that is I will tell you that is what it is means. Magnetic effects of electric current in the lesson of magnetic effects of electric current, there is one lesson is there. There you can learn this electric field is perpendicular to the magnetic field, always perpendicular to the magnetic field, always acts perpendicular to the magnetic field. So the electric charge happens because of the intrinsic property of a fundamental particles of a particular atom. So because of these fundamental particles, it may happens produce either electrical field or as well as magnetic field also. Clear? Next slide. So here we can see clearly, we can observe that there is one macro body, there is one macro, this is one macro body, that body, that means a small body, right? So if there is any deficiency, how this charge will be happens means either maybe it may be deficiency of some electrons, or maybe some deficiency of, or maybe excess of some electrons. That means that we can see in next slide. So that means excess of electrons means it can capture some electrons, the atom can capture some electrons, so that it will be a negatively charged body. That means we know that electron is a negative charge. So to get some negative charge means automatically the body will be converted into the some negative, so that it is a, we can say it is a negatively charged body. Excess of electrons is nothing but a negatively charged. Next one, positive charge, deficiency of electrons. So this is also same converse. If lose of some electrons means it will lose some negative energy, that means it may get some positive energy, that means considered as it will be having some positive power. So that some deficiency of electrons means some lose of some electrons, some sacrification of some electrons means there is nothing but a positive charge. So that is depends on this particular atomic structure. So all this information will be considered as a in the task of atomic structure. So how this atomic structure will be happens. So what is the atomic structure here? Why? Because all we are discussing means how the charge will be happens. We should be know that what is a charge, how this charge will be happens, how this charge will be occurs. We have to know all that, all those, that is clear. Then the atomic structure. Clear. This is the atomic structure. So of course we may learn in our previous classes, so let's will be recollect all those. So that is this is a structure of an atom. In the atom there is a center, one spherical part is there. The spherical part contains in it has two fundamental particles again. First one is neutron and second one is proton. So these two are merged, these two are imaged in particular spherical part. That consideration is nothing but a nucleus. Clear? This nucleus is a center part of the atom, and there is some paths which are followed by some fundamental particles. That paths are known as orbits. The fundamental particles which revolves around a orbit, that fundamental particles is nothing but a electrons. Clear? So electrons always follows some paths. That path is known as orbits. So these orbits always will be occur around the nucleus. Clear? I think it's clear. Next one. Yes. Then if you look on into the nucleus, then we found that proton is a positively charged particle. Yes, proton is a positively charged particle. Similarly, neutron has no charge. It has a no charge. And in the same way, nucleus of an atom bears a positive charge. Already we know, we can conclude by these points. That means in the nucleus we have one proton and we have one neutron. Already this neutron is neutral. It does not have a charge. But protons, there is of course not only one proton, of course it have a number of protons. So these protons have some number of protons. That means the domination charge here is positive. So that finally we conclude that this entire nucleus will have a positive charge. So So that he just explained here, that is nucleus of an atom bears a positive charge. Next, atom is neutral as whole. So coming to the atom is always have a neutral charge. Not a always. In some ordinary conditions, in normal ordinary conditions, it always, so in ordinary conditions only, it have a neutral charge. Here atom is neutral as whole. That is why I said this is, there is already I said, of course, then neutrons are in neutral charge, and there is some protons. So this number of protons is always equal to the number of electrons which are rotating around the nucleus, so that the charge will be get balanced. So here in the same thing, here you conclude that the negative charge is always equals to the positive charge, so that the charge will get balanced under conditions a body is neutral. Next, when this equity or balance is disturbed, if it is disturbed by removing or supply of some electrons, the body acquires a net charge. So here we have some examples. The body will acquire a positive or negative charge depending upon whether the electrons are removed from it or added to it. For example, there is some two atoms is there. First one is hydrogen and second one is chlorine. So already we know, in your previous class we can see that hydrogen atom, I think that is in next slide. Okay, see this hydrogen atom will lose some electron. That means it shares, it gives one electron to the chlorine, so that it donates. That means removal of some electron means removal of some negative charge, so that it acquires a net charge it acquires, that is positive. And similarly, that particular net charge, that particular electron will captured by this chlorine. So chlorine taken one electron from hydrogen. It taken means it additionally negatively charged. It gets some additional negative charge, so that this net charge of this chlorine will becomes minus. That means negative. So by sharing of the electron, hydrogen gets a positive charge and chlorine get a negative charge. Of course, we can say these net charged atoms is nothing but ions. I think you know that. I think your chemistry you may get to that, right? So by the bond, of course, in chemistry part you can learn that both will get some bonding also. The next, types of electrical charge. So what the types of these two these types of electric charge? Yes, there is a two charges. One is something plus is there, oppositely minus is there. Minus is there, there is a positive, plus is there. We may see number of times in our textbooks or maybe in our materials. Number of times we can see that positive charge and negative charge, right? That means plus sign and minus sign. So types of electrical charge, that is so two types of charges is there. One is positive charge, that is positive charge means that already we will discuss. The positive charge means the deficiency, the lose of some charge, that is positive charge, and the excess, that means to gain some electrons, is nothing but a negative charge. You get an example with the hydrogen, HCl, hydrochloric acid, and the same way NaCl, sodium chloride. Next, here you can learn charging by friction, how the charging by friction can happen. That means there is one best example. For example, if you most of the girls they can know. Just a minute. Mostly the girls can know that uh, when they are combing, when they with the oily hair, when they are combing, that means they are continuously getting some combing. When the comb after that, when the comb will be came near to some piece of papers, it will be attached. It will be attracts. The comb will attract that piece of papers. So automatically they get attached. So how this will be happens? And similarly, if you almost all either boys or girls, whatever maybe uh, they can know that they can experience that if the pen or pencil is rubbed on the class P in a fast manner, if they uh, came near to that particular piece of papers, then it will be attached to the particular pen or pencil. So by this, that means there is some, because of generation of some heat energy, that means heat energy means by friction there is some rough surface. So because of some that rough surface, the ions will be reacted, the charges will be reacted in that particular atom. That means because I am supplying heat energy because of the friction, so this heat energy gives us some additional sum of energy to stimulate the electrons in that particular atom. So these electrons will be making some bonding with the ions in the paper, so that it will be both get transferred, so that the charge will be happen, so that it will be attracted itself, so that it will be attracts the piece of papers. Similarly, by charging on the some friction also, so both the bodies develop equal and opposite charges. Both the bodies develop equal and opposite charges. So finally, charging by friction, that is body, here there is a two bodies, hydrogen and chlorine. So hydrogen has a highly electron affinity, that means attract some of the electrons from other, that means hydrogen, chlorine, yes, this is something I given that because of the friction there is heat energy will be occurs. The input is heat energy, then because of the heat energy the output is here, the arrow mark is showing the output is here, electrons get excited. Clear? Actually from hydrogen, the hydrogen will loses some electrons, the chlorine will be captured those. So by losing the electrons is known as the electron affinity. The capacity of losing electrons is known as the electron affinity. Attracts, so then the chlorine will attract some electrons from other, that means from hydrogen it will be attracts. Here next one, properties of this electrical charge. So what are the properties of this electric charge? So like charges and unlike charges, like charges always repel, we know. If there is some equal strengthy persons is there, always they will be ready to be quarrel. They are each other ready to quarrel each other. They will be prove their strength themselves in a always they are trying to prove their energy levels. Like this, like charges actually repel each other. We know the positive charge will always repels the positive charge, and also negative charge will always attracts the negative. In the same way, unlike charges attract each other. Of course, if there is some small boy, some small kid with you, of course he is not a strengthy with you, strengthy like you, but as a small boy you can you can invite him, and you just kidding with him, and you can spend some joyful time. That means you can give some affection, you can show some affection. Similarly, unlike charges attract each other, that means positive will always attract the negative, and negative is always attracts positive. So unlike charges is always attract each other, and like charges always repel each other. And charge is a scalar quantity. So yes, charge is a scalar quantity. What is a scalar quantity? That means it does not have a direction. Clear? How we know that the quantities are two types: vector quantity and scalar quantity. Vector quantity, which is they have a direction as well as magnitude, but only having magnitude, those type of things is known as scalar quantities, right? And charge is always quantized. Yes, we can measure how much of charge it will be done. That means by mobile I am saying 80% it will be completely charging. So that will be charge that will be quantized. Quantized means we can measure is that is measurable. That means 1 kg amount is 1 kg some item I bought it, and 2 kgs 3 kgs, these 1 kgs 2 kgs 3 kgs is known as quantized. That means 1 2 3 I can measure with some numbers, so that is quantized. And charge is conserved. Yes, you can be conserved this charge from one state to another charge, another type. That means if the I can convert electrical energy into heat energy by the electrical heaters, by the micro ovens, fridge. Like this, I can convert the charge of solar energy into some electrical energy or some heat energy. Like this, I can also convert the wind energy into, yes, those are also some charge. This is clear. Then next, charges is always associated with mass. Yes, charge is always with the corresponding to the mass. That means very higher mass will gives more attraction. If the mass will be decreased, then it will have some less force. Next one. Yes, the SI unit of the charge is, of course we know there is a number of units, everything have some unit. So the SI unit of a charge is coulomb, and the letter that will be denoted this coulomb is C. So the SI unit of charge is coulomb, the unit of the charge is coulomb, and this coulomb can be represented as COULOMB. This coulomb can be represented as C. So charge 1 coulomb is nothing equals to the 6.25 into 10 power 18 electrons. Here in the left side, here in the right side is shown 6.25 into 10 power 18. 6.25 into 10 power 18 electrons is there. Similarly, if here nothing but 10 power 18 means after 6 there is a 2 decimal points. So by dividing, so wrong 6.25 ఇది ఒకసారి వెరిఫై చేద్దాం. by 100, right? By 100, yes, 6.25 into 10 power 18 by 100 చేస్తే that it will be become 625 into 10 power 18 minus 10 power 18 right, 10 power 18 minus 2, that is 10 power 16. So that is 625 into 10 power 16 electrons. Okay, so that means 1 coulomb charge moved means how many electrons those are moved, that is 625. Later we have to put 16 zeros beside the 1. So its product 625 into 1 after 16 zeros. So such a electrons, if they transmitted or moved, then it is known as 1 coulomb charge is moved, passed, right? Very great thing, right? In the same way, electron power is also same converts. One electron, the power of one electron is 1.6 into 10 power minus 19 coulombs. 1.6, that means 1.6 by 10 power 19 means 1.6 by divided by, after 1 we should put after 19 zeros after 1 in the denominator part. Clear? Next, Body has a positive charge of 1 coulomb means normally due to share of, that means if it's loose, right, if it's loose 625 into 10 power 16 electrons, then I can say it has a then it have a positive charge of 1 coulomb. It loses 625 into 10 power 16 electrons. Next, if a neutral body is made positively charged, is there any charged mass? If a neutral body is made positively charged, if there is a one neutral body, this does not have any negative charge or positive charge, is made positively charged. If it is charged positively, is there any change in its mass? Yes, that means it loses in the down. We can get some explanation. The change is extremely small or negligible, of course. That means it for example, it lost 2 electrons means it will get +2 charge on there. That means comparing with the entire atom, the weight or the power of electron of course may be very less. It means if there is some few electrons if removed, means of course there is some already we decide we know that charge is a scalar quantity. That means it has some magnitude, so that of course maybe a small amount of magnitude is removed. That means mass will be, there is some decrease of some mass. Of course it may be removed. Of course it may be lost 1 coulomb charge, means it may be lost 625 into 10 power 16 electrons. That means of course it's a loss of high charge. That means loss of much scalar quantity. That means of course loss of some mass. So thus the mass of the body will be decreased. Of course, depending on the situation, we may notice that depending on the number of electrons, depending on the loss of number of electrons, we may detect is there any loss, or it may be a decrease, or it may be increase. Here, of course, if it happens in the bulk, we may find out that. Okay, next. Yes, and then static. This electricity will be again classified into 2 branches. One is static electricity. In the next slide, you can see the current electricity. So, what is the static electricity? Is nothing but some branch of physics which is study of the electric charge which are in the rest position, and there is and this charge will giving no effect on its surroundings, then we can say that is a static, that is in rest position. Of course, that is in some neutral position. That means we have to study about the charges which are in the rest position. That is nothing but the study of the rest position charges is known as a static electricity. In the same way, current electricity. So how this current electricity is means, this is also a branch of physics, and which is study of electric charges. That means which the charge is in motion and it will give some effects on its surroundings, then it is known as current electricity. The study of the motion, the study of the charges which are in some motion, that study is known as a current electricity. Clear? Next one. This is the important which is entering into the word. All those are of course. Still now we learned about the fundamentals as well as some IIT level. Those are clear. And now we should be learning about the electrical field. What is the particular topic of this electrical field? Means there is one example. I am here in your classroom. So in these 45 minutes, what thing I have to notice is that what is my possibility to know about my surroundings, what is my power to know, what is my influence to know what happening. That is only I can know. I can detect something. I can find what happening in this classroom only. I may can't able to identify what is happening out of this classroom, what is happening in at the school gate, what is happening at the out of Vizag city. So what is my influence? I am here, I can only show my influence, I can only find out what is happening in our classroom only. So that's my range, so that's my field. Out of this classroom I may count. So similarly, there is a one charge which shows that's range until into some area only, some particular area only. If this area will be exceeds, means it may can't give any influence. That means the power will be lost. The power will be it cannot show its power. That means the charge will shows only its strength only in the particular area. That means if it will be cautioned, any other charge will be came to near that, no, it's my area, you should be get out from here, so it's my area. That means it can be shows it will influence into particular range only. Other if there is some after that boundary, it may can't exist, it may can't, it may helpless, it may can't give any influence on the particular charge. So that only if here for here only it will give some influence, after them it may can't, it will be it may can't go. So that particular area is nothing but a field of particular thing. In the same way, for the there is some electrical charge which shows some influence around some area around it. That area which it can show some influence is nothing but a field of this charge. So here this charge is an electrical charge. So this electrical charge shows some influence around it into some area only. So that is nothing but a this electrical charge shows its influence on particular field. So that it is known as electrical field of particular charge, particular that charge. Clear? Here I taken a one charge. That charge will shows its influence. For example, in this blue color area, it shows highly influence, highly it will shows it will give highly effect, it affects more towards what the charge it want to enters into it. It shows some highly impact on that. That is I can cover with that in the blue color. Similarly, after the blue color, after the boundary of the blue color, it will be I shown that it will be in a light green. That may be of course there is some influence, but it may be less. So just for identification I given you. So just for identification I given the picture there. Similarly, the out of that light green color, it may not shows its influence, that maybe it can't attract, it can't repulsive. So that particular influenced area is nothing but its electrical field of particular charge. That means here these charge also give repulsion force to the same like charge. Similarly, this charge will attract with some force to that unlike charge within their field limit. So the test charge experiences no force at a point. Test charge experiences no force at a point means the electrical field at the point must be at 0. That means must be 0. It means there is no influence. Clear? Then here is shown E equal to electrical field intensity. So at the center there is some unit positive charge. So at the center there is some one unit positive charge. So very near to this positive charge have a some high influence, is nothing but a very high intensity. After then crossing that some distance, some boundary, the intensity will be some more less when compared to this area, this violet color area. Then the light green area will have a some intensity which is lesser than this high intensity area. After then there is some other colored area that is will be, that means which is far from the unit positive charge, will decreases its influence also, its intensity also when it is far from the charge. That means here in this particular colored area the intensity will be some less, and the out of that area the influence may be completely loses, that may be completely zero. That means at there the net charge which is the influence or which is the intensity will be zero. So until here only, until up to this area only, that circle, that colored area only, it shows its own influence, that is nothing but its intensity, that is nothing but its field intensity. So here I taken a electricity, here we are discussing here only for electricity, and also we are discussing for electrical charge. It shows some field around it with a some intensity, with a some level of intensities. So that I said there is some electrical field intensity. Intensity means its influence depending on its nearby distance. So I consider there is a charge, there is a point charge, that there is a q naught there. So this q naught, on this q naught there is a some force which is shown because of the unit positive charge which is in the center. So that is that unit positive charge which shows some charge on that particular point charge q naught, which I taken to into its field. So that force on that particular point charge is known as electrical field intensity, that is represented with E. That is the equation is E equal to F by Q naught. The next, this electrical field, the electrical field is a vector quantity. That means already we discussed scalar quantity. Scalar quantity is nothing but only have a magnitude, but this is a electrical field is a vector quantity, means it has also have a magnitude and also have a direction also. So electrical field, of course it has a units. So this electrical field units is Newton per coulomb. Why? Because that E equal to F by Q naught. So F, the unit for F is already force is Newton, and the charge unit for charge is coulomb, that is Q naught, that is Newton per coulomb. Here it is in the red colored there is a mention, that is N by C. There is nothing but a Newton per coulomb, which is a units for electrical field. Next, this is a major thing, one important point, basic point in your lesson for start. In your lesson, which is at your starting, which is at the starting position. So electrical potential. So electrical potential means, that means amount of work done to bring a unit positive charge from infinite distance to into that electrical field. How much amount of energy we used, how much of energy means how much of work we will done, it is nothing but an electrical potential. So there is a consider, there is one point charge, that is Q naught. That Q naught, I used some work, I used some energy to do the work to bring that q naught positive charge into nearby or hero, that is nothing but this charge, this blue colored charge, into this field of that particular charge. For example, I said this is a small capital Q, so I want to bring the point charge q naught into the field of the bigger q. So I need to do some work. Why? Because for example, this q naught may be a positive charge, and also this charge will be also a positive charge. So I have to do some work against the repulsion force acts because of this bigger q, right? That means I have to do some more work. That means, so how much work I used, so that can be known as, represented as electrical potential. So that will be different at different areas. For example, if I want to take it to near to the charge, that means I have to use some more energy. Why? Because repulsion is very high near to it, which is in the that nearby color. For example, whereas in the outermost ring is there, that is covered with some another color. So if I want to bring at there only, I should be use some less work, some less energy. I have to do some less work. That means I have to give some less energy to put it on the outermost cell, right? So that there is some variation of using energy. So how much of energy I am using, that is nothing but a electrical potential, without acceleration or without a change of kinetic energy. Yes, without, the speed should be constant. That means the amount of work done that I am using, that means because of my work, the acceleration should not be occurs at the moment of the positive charge. That is nothing but a kinetic energy. If I change the energy levels, then automatically there will be acceleration occurs. So here the condition is without acceleration, without giving any acceleration. That means no change in its speed, and also without change in kinetic energy. By these conditions, how much of work I can do to bring that positive charge from infinite distance to particular point in that particular field. That amount of work is nothing but electrical potential. Why I said this specifically mentioned, that means the electrical potential, that work done on the unit charge, is depending on the charge which we taken. If I taken 1 coulomb charge, it will gives, already we know the charge is depending on mass, corresponding to the mass. There is if the mass variation is there, automatically in the conversely the influence also, that means the charge is also different. Similarly, if I taken less mass, that means 1 coulomb or 2 coulomb charge, it effect is of course less when I taken of course less comparatively when I taken, for example, 100 coulomb charge, 200 coulomb charge, it is comparatively less, right? When I taken 1 coulomb or 2 coulomb charge, this effect is comparatively less if I taken 100 or 200 coulomb charge. So the effect will be comparatively less. So the amount of work done to move some to move some point charge from the infinity to this field, this electrical field, that is nothing but an electrical potential. Same equal to the next, electrical charge flows conductor. If the electrical charge flows through a conductor, that is nothing but there is an electrical current, nothing but there is a passing on electricity. So this is the clear picture explaining that if the electrical charge flows through the conductor, then we can say there is some electrical current in the conductor. Next, switch. Switch is a conducting link between either the bulb and the cell. That means switch is the link between the electrical circuit. Later on we will discuss about the circuit. Clear? Just see the introduction. You can see here. Switch makes conducting link between bulb and cell. And then now electrical current. So here this is electrical current as well as electrical circuit. That means a continuous closed path of either by using metal to which need to circuit the electricity, circulation of electricity. That is nothing but an electric circuit. It should be a continuous and a closed path which allows to move the electricity is nothing but an electrical circuit. If the circuit is broken, means there is no electricity passing through it. That is, current stops flowing. If the current does not flowing, means bulb does not glow. That means electrical current E. Electrical current can be represented with the E. That means nothing but electrical intensity is also E. Then amount of charge flowing through a particular area is Q naught. Amount of charge we can represent with the Q naught. Here amount of charge or charge is represented with the Q naught. Amount of charge flowing through a particular area, it is flowing. That means charge is moving. So finally, whatever may be, the charge can be represented with Q naught, and unit of time can be represented with T. So finally, what is electricity is before that. So this is about electrical current circuit. So already we discussed. Before that, we should be discussed with about electrical circuit. So already I said electrical circuit is a continuous closed path. By that only it will be electricity will be passed on. So how this electricity will be passed on? What the circuit contains means the circuit contains one battery and also have a appliance. Here I am using the bulb as a appliance, and it will be connected in series connection only. There is a connect, and it will be connected to the device known as ammeter. So then it will be connected to the negative terminal of the battery, since this battery is also included in circuit. So this, if it is closed path, then I can say it's a complete circuit. So what the circuit includes means that's a battery and the bulb, and here ammeter, and it will be connected to ammeter, and there is a one switch which is operating to allow the current or to stop the current. So and it is finally connected to the negative. It will be connected to the negative terminal. So in this way circuit will be constructed. Of course some other also we can use, but this is the basic circuit diagram. So when the electricity will be passing on means if there is some chemical reaction will be start on the battery will always gives electrical potential only, not a current. So if the electrical potential is supplied, then the movement of electrons is there. So the electrons can be moved from here. That means the switch will allow us to move the current. That means to close or open the circuit. If the circuit is closed, then automatically the movement of electrons is done. That means the movement of electrons means that the movement of charge. The movement of charge means the flow of current will be done. It will be passing through the ammeter, and it will be reaches to the particular appliance, and it will be reaches finally it will be to the positive charge. So in this way the electricity will be passing on. The electrons can be the charge. Electrons means nothing but a charge. The charge will move from one terminal to another terminal. So then finally I can say there is a passing on electricity. nothing but a passing of some charge. So finally electricity current I, it is represented with I, is defined as the movement or passing of a some charge in a unit area at a particular time is nothing but electricity. That is I is equal to Q by T. It is defined as, of course we know before, the charge can be represented with the Q and the time can be represented with the T. So finally I current is represented with electricity, or current is represented with the I. So that I is, that means current is defined as the movement of, or some displacement, the movement of particular charge at unit area at unit time, per unit time, is nothing but a electricity current, that is nothing but a I equal to Q by T. Then now in electrical circuit, direction of electric current, direction of flow of electric current. So direction of electric current is always opposite to the direction of flow of electrons. Next, then finally some key points about current. The current I represented with I, which is the SI units are here ampere. I didn't mention the SI units of current is ampere and the charge units is coulomb. That is, the loss of 1 coulomb or gain of 1 coulomb means, here I mentioned 6 into 10 power 18 electrons, that is charge of coulomb, and loss of 1 coulomb charge means it losses 6 into 10 power 18 electrons, and the power of electron here, the charge of electron he given that 1.6 into 10 power 19 coulombs. So here we learned about some particular terms, that is charge. Already we know the charge, which gives charge means which gives some influence around it, that is nothing but a charge. So this charge this charge happens because of this intrinsic property of atom. The intrinsic properties happens because of the fundamental particles, the chemical reaction between the fundamental particles, and then current electricity, that is nothing but a I, that I equal to the amount of charge moving per unit area, moving at particular unit. The electrical charge means the current electricity I is defined as the moving charge per unit at particular area per unit time is nothing but a current electricity. Then the units of electricity I is nothing but a ampere, and the units of charge here, it's some matching is there. The charge coulomb is a unit of charge, and ampere is a unit of that current electricity. That means here finally ampere is defined as flow of 1 coulomb charge in, of course at a particular area, in 1 second. Flow of 1 coulomb charge in a particular 1 second. Flow of 1 coulomb charge in a particular 1 second in a particular area in 1 second is nothing but a ampere. Clear? The next, so small quantities of current, of course there is some quantities also in the current. The small quantities of current is nothing but a first one is milliampere, second one is also macroampere. So this milliampere means, this milliampere is represented as 1 mA, that is 10 power minus 3 amperes. That means there is a 10 power 3 fractional part on 1 ampere, and macroampere means that is 10 power minus 6 amperes. Then there is a one device which is used as which is used to measure the electric current, that is nothing but a ammeter. And here there is a something shown, that is a known as ammeter. Ammeter is a device which is used to measure the electrical current which is passing through in that particular circuit. So ammeter is a device which is used to measure the how much electrical current will be passing in that particular circuit. Clear? This is a device which is connected always in series in the circuit. Next one, electrical current flows from positive terminal to negative terminal. Clear that electrical current is always moving from positive terminal to negative terminal. That means electrons will be moved from negative terminal to positive terminal through ammeter and switch. Of course, all this is can be shown in the circuit. So positive terminal to electrical current will be transferred from positive terminal to negative terminal. I will explain clear about this. So I will give you some example why I am saying that. So clear, there is some difference. Electrical current will be always moving from positive terminal to negative terminal. So that means not in the same path of movement of electrons. That means electrons are always separated from the negative terminal, right? Because it's a negative charge. But I said the electricity will be always moving from positive terminal to negative terminal. Means if the electrons, for example, if you take your classroom, I just at the bell rang and I just allowed to go student one by one. If I allowed to move first person, that means the vacant position is there. If I then, that means the first person moving towards the door, but the vacant place will be moving from first person place to second person. But the person who is moving from second place should cross the first person. Then he will be move towards the door. That means the person will be allowed to move in one direction, but the vacant place will be moving to the opposite direction, right? The vacant place will be moving to the opposite direction, means that will filled with another boy. Clear? So this vacant place, the movement of vacant places will be opposite direction to the movement of the persons. That means the electrons is moving in one direction, means that means the negative charge will be moving in one direction, in the opposite direction, means that means the vacancy of electron, the vacant place of electron will be moving in the opposite direction. That means the electrons are moving here, means the electricity will be moving in the opposite direction. Here I can for the clarification I would like to give another example. Before, do you know, at the time of invention of electricity, there is no invention of electron. Yes, there is no invention of electron at the time of invention of electricity. They thought that the movement of some positive charge is nothing but an electricity. Later on, electron will be discovered, but these positive charge will be happens, the movement of this positive charge will be happens only because of the movement of the electron. If the electron will be moves, means the positive charge there is some vacant place to move the positive charge. So actually these positive charge is known as, that vacant places is known as holes. That means the movement of the holes will nothing but an electrical charge. Of course, it may be some additional information and out of the syllabus, but you have to know that. Why I said the electricity will always move from positive terminal to negative terminal, but electrons are moving from negative terminal to positive terminal. Why I said, this converse will be happens. Clear? Next, metal conduct electricity. Yes, always metals will conduct electricity. That means they have some free of electrons. so that it will be good to allow electricity. So electrons are very able to travel in a perfect solid crystal. Why? Because it has some free of electrons. Why? Because, and in the same way, electrons can easily, smoothly and easily can travel through the perfect solid crystals. And motion of electrons in a conductor is different that charges in empty space. Yes, motion of electrons in a conductor is depends on the how much capacity of charge it have and how much empty place it have. So that depends on the, of course, this is small logical thinking, that's only the students doubt. So motion of electrons is depending on the charge, how much empty space is available, how much availability to move the charge from one place to one place. It's a vacant place like that. For example, I just given a I just asked one person, one student from you, just run in the classroom. How much of speed you can run, you can run. I just given some instruction to one boy. So how can they run? When comparing with, of course, there is a no benches and there is a no students in the classroom now, then I will, there is a case 1 and there is a case 2. That is, there is no benches, there is a no students in the classroom, and then now I asked that boy, you can run, how much of fast you can run. So which is faster? Either case 1 is faster or case 2 is faster. That means while the students and benches the classroom have, if he can run at that time, or there is a no benches and no students in the classroom, at that time he can run very fastly. In which case he can run? Yes, that there is no benches, that there is no students, he can run very fastly. In the similarly, how much empty place is there, how much free space is there, then electron can move according to that, right? I think you can understand that. Next, if the difference of pressure, electrical pressure, so what is the potential difference? Yes, already we discussed about the electrical field. So there is some, that means electrical field and electrical potential. We discussed electrical potential means that means how much of work I can do to bring a one positive charge from infinite distance from some other place to into the particular field. But I given some different colors also. At border it will gives some type of influence. No talupe mailadu idhen now. Yes, so there is some difference to bring this point charge to the border of that colored area, and there is some difference I shown you, that is in this presentation, that image. Yes, this one, for example, that q naught charge, if I want to bring this q, there is some difference. If I want to the charge, this q naught charge will be moved to the outer circle. There is a 3 circles, right, around the charge. That is the nearby circle is, let's think the nearest circle is 1, and the next is 2, the next is 3. So there is some difference to do the work to bring this q naught to the third circle is different, that the work I can done, that the charge will be to get into the first circle, right? there is a difference to bring case 1, that is to bring q naught to the circle, third circle, is different. That is the case 2, which is, that means to bring the q naught charge into the circle 1, that is case 2. So there is a difference between, there is a work done difference between the case 1 and case 2, right? That difference between this case 2 and case 1, that means to bring, to do the work between the different positions in that particular field, to bring the positive charge from infinite distance at different places in the one charge field. That difference is nothing but a potential difference, right? There is some difference, obviously, there is some difference. So that difference is nothing but a potential difference. I think it is clear, right? So let's we look on one more time. What is the potential difference? Yes, if there is difference of the electrical pressure, right? There is some pressure. Let's take one example of balloon. If I pump it with some air, if I want to press some little bit amount, it will opposes with some less force. If I want to press some more, means towards the center, it will show much pressure. That means there is a difference between, in these two cases. If I want to just press little bit, it shows a less opposing. If I want to press some more, it will shows more opposing. That means it will opposes with pressure different in different cases, in different two cases, right? So in the same way, if I want to bring that point charge, how much of near to that point charge, near to that particular charge, it will shows when I am moving towards near to the charge, near to this charge, then it shows different pressure at different places. If it is very closer, it shows high pressure. If it is not closer, it is far from it, it will shows less pressure. So that if the difference of the electrical pressure, then the electrons move only. Yes, because of the difference, we have to give some more work. That means because of this pressure, we have to give some supply of more electrons. So the potential difference along the conductor means there is two electrons